Hello all, welcome to the session of mechanical system design. In today's session we'll discuss about statistical considerations in design. I am R.V. Bhaskar, assistant professor in mechanical engineering department, Kekivag Institute of Engineering Education and Research, Nasik. So focus of today's session will be exactly related with statistics and what are the considerations related to design. So different mechanical systems such as shafts or either we can say IC engine components or many components are there, so that are to be related with the statistical data, maybe during manufacturing or maybe during the process operations. So before starting with the exact design session, first we'll try to understand what does exactly the basic statistics means. But before that, so what we'll be discussing, so regarding the statistical knowledge of probability and standard statistical distribution, that is maybe related with a histogram or a central tendency. So such factors we'll be discussing, or either we'll be able to consider the different data collection methodologies, and then we'll be discussing about natural and design tolerances related to statistics. So that factor will discuss about maybe related with sigma and standard deviation and variance. Then we'll be discussing about the margin of safety, factor of safety we can say, or either then we'll be discussing about the reliability. So life factor considerations will be there. So starting with the session, so exactly statistics, I think this statistics you might have learned from your 8 9 standard. So start just getting an overview related to statistics. So statistics has been origin from the word statista, or we can say a Latin word of status, which was in German called as statistic, which means a political state. So father of statistics, Sir Ronald Fisher, has developed this statistical concept in relation with the data contribution and data collection, and how to distribute or how to collect the data and how to represent it. So representation styles related to our processes, manufacturing, or maybe any automobile industry can be related with some sort of statistics. So exactly what does the statistics means? So the word statistics and statistical are both are derived from the Latin word, as I discussed, that is a political state. So in turn, how we will relate this statistic in our case, that is the state of manufacturing or during manufacturing. So there are number of components are to be manufactured, and out of that many of the components may have defect parts or defective parts, or either there might be some sort of defects in that. So that status will be collecting maybe as an observations, and that observation data collected maybe in numerical form will be analyzed. So what does the steps will include? That is statistics in concern with the scientific methods, that is collection of the data, numerical data of manufacturing, or organizing that data as per requirement, maybe ascending order, descending order, or as per the type of statistical method which we'll be using. And then all the data which is collected is to be summarized with the required data, and then the summarized data is to be analyzed and presented. So presentation of this data will be maybe in the graphical form, or either maybe in a flow chart pattern. Then as well as deriving valid conclusions and making reasonable decisions on the basis of this analysis. So exactly what is the requirement of statistics? So we have to derive some sort of conclusions from the data which is to be collected, that is whatever the component manufacturer, or if we relate it with the profit status of any industry, so number of manufacturing methods are there, number of products are manufactured, but out of that whether the manufacturer is in profit or not, so same thing can be related with that, but our focus is exactly related to manufacturing terms. So maybe related to shaft, specifically mechanical systems, lathe machine is there, milling machine is there, or either if we concentrate on factors of gears or exact components, so shaft, bearings, gears. So many components are there, and their manufacturing status any factor will be considered. So statistics is usually used to refer. So what factors it will refer? First one is numerical facts, such as the number of people living in a particular area. This is a general example, so we can use that. Or either we can say the study of ways of, so there are different ways of studying or collecting or analyzing and then interpreting those numerical factors. So what we just focused on in our learning objectives. Then this small picture will represent a huge thing, that is, unless and until statistics is used, so either we can measure or either we cannot measure. So the thing which is measurable will come under the category of statistics. So statistics, there are a number of definitions provided by a number of pioneers in statistics. So that is, statistics may be defined as the science of collection, presentation, analysis, and interpretation of numerical data from the logical analysis. So this was given by Mr. Proston and Cardon. So according to them, the data is to be collected, then again it is to be presented, maybe with the help of number of tools, and then the same data is to be analyzed and analyzed, and then will be represented, or either we can say interpret it. So that may be in the form of a small photograph indicates, maybe in the form of a graph, or either maybe in the form of a hierarchy, or either maybe in a form of a pie chart, or either we can say that a Pareto chart. So there are a number of statistical methods. Now coming to the point, so when we move on with the collection of data, so there always is a chance of rising the error. So error will always occur. So what are the reasons or causes for the variations? So that factors are to be first understood. So they first are classified into two categories. So exactly what are these causes? So first one is assignable cause and second one is chance cause. Because if the variations are observed or the given data are beyond the acceptable level, so it is necessary to identify the reasons for variations in apparently identical components. So first one, assignable cause. So exactly what does assignable cause means? That is, not occurs at random but due to some of the reasons. That is, so assignable causes do not occur at random but are the results of changes in the material, or either we can say manufacturing processes or inspection processes or operator. So that means the assignable causes may be attributed or to something due to materials, machines, including different measuring instruments or either different workmanships. So either we can consider one example. Suppose there are we are going to consider the number of diameter of shafts. So during manufacturing, so each shaft which is manufactured will vary or will not be identical. So this may happen due to the tool wear for every shaft processes. So the tool wear will become our assignable cause. So this is about the assignable cause. And when we come to chance cause, so chance causes occur at random, that is complex or unknown parameters which cannot measure or trace. That means they occur at random and are due to complex or unknown parameters, so which cannot be neither traced or either cannot be measured. That means they are natural or to process or occur even though all conditions have been held at a constant as economically possible. So though we consider all the factors. So another type of variation combining both the tools, we can say that chance cause or either we can say a constant cause. So what does exactly it means? When all assignable causes of variations are located and removed one by one. So if we consider the change of material, manufacturing process, or either this inspection, so one by one they are removed and the desired state of stability or control is attained. So this process is then called as a chance cause system, or intentionally we'll call it as constant cause system. So these are the factors of variations. So first two, assignable and chance causes, are to be understood. Then next comes the factors related to terminology of statistics. So what does exactly the statistical analysis will involve? So these three factors are to be understood first. So out of that, first one is population, sample and random variables. So what does exactly population means? So during the entire group of apparently identical components or an element is called as a population. That means, so a total entire system of different components will constitute together to form the different populations of the component. And then second factor when will come into picture is nothing but a sample. So it is exactly, if we can say, the small portion out of this total population selected randomly during the observations. So it will called as a sample. So what we have to do exactly, the total population, out of that we have to select a small sample. So third terminology is related with random variables. So different variables we are going to consider during the design, that is maybe such as length is there, diameter, strength factor, etc. So there are number of factors or variables we call it. So and which these all factors which are under consideration of each component or element in a population or a sample is known as a random variable. So these are the three terminological terms which are to be understood before starting with the different distributions or statistical methods. Now next comes the distribution, that is frequency distribution we call it. So all the data which we have collected. Now it is to be distributed, or how to collect and analyze this data. So for that we have to understand the frequency distribution. So in any statistical analysis, when a large number of observations are there, if we have different number of observations, say over here we have an example of a newspaper, number of newspapers sold during the last 10 years. So the large number of observations of random variables we say are made from a total population or maybe a sample. So it is necessary to represent the data. All this data is to be represented in a systematic fashion or systematic manner we can say. So before further analysis is to be done. So this most common method used to represent this all raw data we can say over here. So this representation we call it as a frequency distribution. So frequency distribution is nothing but a representation of raw data in a systematic way or manner and in a useful manner. So we will prepare a table considering this is one example of a newspaper sold during last 10 years. So what we have is, so how many papers were sold? So papers sold in last 10 years, suppose 18 papers were sold, 19 were sold, 20, 21, 22 likewise. So how many times 18 papers were sold? So the occurrence frequency is provided over here, that is 2 times. How many times 19? 0. So likewise, so 25 papers in a day was sold one time. So this is the distributed data and it is to be systematically arranged. Now this is the frequency. Now if we have to group this frequency, that is we have to categorize in the form of a class interval. So what exactly difference between class interval? So if we consider two margins, that is suppose one table is provided over here. So 15 to 19 is one margin or a class interval we say. So we have distributed this data into intervals. So 15 to 19 is first, next is 20 to 24, another is 25 to 29. So this data will be represented in the class frequency. Now 15 to 19 if you consider, so 15, 16, 17, 18 and 19. So how many papers are sold within that? We have 2. So this is the 2 is the class frequency. Then we have 20 to 24. So starting from this 20, 21, 22. 23 and 24. So how many we have? It is 4 plus 2, 6, and plus 1, 7. So this is what we can say. So 20 to 24 is this much. So 4 plus 2, 6 plus 1, 7. So this is 7. And then we have 25 to 29. So 25 to 29 is only 1. So the frequency is grouped together and over here. So this is all about the this. Now 15 to 19 indicates, out of that 15 and 19 indicates lower and upper class limits, and 19 minus 15 will indicate the class width. So that is 4 is the class width. So coming to the next part, that is the methods of frequency distribution. So there are usually two methods. First one is histogram and second one is frequency polygon. Now what does exactly histogram means? So graphical representation of data, that is distribution of numerical data together constitute, that is suppose we have a set of rectangles and each set of rectangle will constitute the base as class width, this one, and while the height we have represents the class frequency. So it is nothing but a graph. Histogram will be nothing but a graph of frequency versus the factor. So it conveys the data to the viewers in a pictorial form, obviously. So for that we have to consider few examples. So suppose we have an example of temperature recording in few cities in degree Fahrenheit. Now so class frequency and class boundaries are to be plotted. So class boundary in our case will be the temperatures, and that are in the form of a class intervals as we have discussed earlier. So starting from 99.5 to 104, likewise these are different the class boundaries. And then we have frequencies. So how many times or in how many cities this has occurred? So 2 times the temperature was over here. So 18 times was the degree temperature, degree Fahrenheit temperature in case of 9 and 114. So and then when we plot it over here, so first frequency of 2 we have over here, orange color indicates 8, 18 between the temperature range of this, and in yellow color we have 7 frequency, and then we have 1 frequency for a specific class boundary of 124 to 129 likewise. So the bar type of a graph will represent the histogram. Next we have frequency polygon. So it is somewhat similar to the histogram, but it just consider the midpoints of the histogram. So suppose this is an histogram, so midpoint, so half average. Suppose we have 99 over here and 104 degree over here. So 99.5 plus 104 divided by 2 will indicate the midpoint for the specific bar of a histogram. Then next we have an suppose 104 degree Celsius, with that we have 109. So midpoint of this will be in this fashion. So 104 plus 109 divided by 2 will indicate the 107 will be the midpoint. So if we consider the class boundaries over here, then so midpoints for each class interval we have got it. So we have to calculate it, and then same are to be plotted in a line form. So we call it as a frequency polygon. So in this fashion we will get the frequency polygon. So this is the second method of representing the different frequency distributed. So the data which is collected. Now just a representation style is not important. Another thing which is to be discussed is nothing but the parameters. So what are the parameters of frequency distribution? Because for analysis purpose the data which is collected is to be considered. So there are two methods of frequency distribution, so or two parameters we can say. So first one we have central value. So for all the collected data we can either find out the central value, or we call it as a central tendency in case of statistics. And second we have dispersion. So dispersion is nothing but the variance, or we can say variation of the data from the central tendency, or either the spread of the data So these two methods are to be discussed. So under the category of central tendency, we have subcategory or sub three types. We call it as first one as arithmetic mean, second one median, and third one mode. Now we'll try to understand one by one each. So arithmetic mean is just a general term which is equal to the actual averages, that is mu will indicate as arithmetic mean. So we have if number of observations, if we represent it with the help of x factor, suppose x1 x2 x3, so likewise till x to n number here xn, so the total number of observations and summation of that will have in the numerator and divided by total how many observations are there. So total will be nothing but the average of that. So that will indicate the central tendency for the collected data. Next one, if we have provided with the frequency, so we can consider the multiplication of observations with respect to frequency of occurrence, and then we can divide it with the summation of the number of total frequencies, or either with the help of number of observations. So second we have a median, and third one is the mode. So we'll try to understand. So central value, there is always a central value where the frequency of observations is maximum, while the remaining observations are spread symmetrically about the central value. So when we consider one central value, central tendency, that will be related with mean, mode, median, so out of that only other data which is collected. So a good example is, suppose we are manufacturing a shaft. So shaft will have different dimensions, since it is not, or we are not able to manufacture the identical dimension of shaft. So there is some sort of variations. So that variation will be either maybe positive or negative terms. So for that purpose we have minimum observations and maximum observations for both. So suppose if we consider the first factor, that is mean. So mean, as I told you, is nothing but the summation of all the measurements divided by total number of measurements. So same, suppose we have data as x1 x2 x3 and capital N will indicate total number of observations. So we can divide it, that is summation of xi divided by n. So we'll get the average, or we call it as arithmetic mean. But when we have frequencies considered, so this is the table related with only x data, and we have second column related with the frequency. So x represents the data collected, and second we have a frequency of occurrence for that data. So another formula will come into picture, that is mu is equal to f1 x1 plus f2 x2, likewise summation of all divided by f1 plus f2 f3, likewise till number of total frequencies. So that formula will be equal to summation of fi xi upon n. So again this factor will provide us the arithmetic mean. Then we have median. Again it is related with central tendency. So what does exactly median means? So it is nothing but the middle value that separates the higher half from the lower half of the data. Now how we can get this higher half and lower half? So for that purpose, suppose one example is provided over here, we can say that we have collected numerical data, maybe height, maybe some sort of data, that is suppose 11, 4, 9, 7, 10, 5 and 6. So for that purpose we have to first arrange the total data in an order, we can say in ascending order. So all the data is arranged, that is 4, 5, 6, 7, 9 and 10. So median will represent the central value. Now in this example what we have got is the data which we have 7 is the mid term, so that we call it as a median. But in this case it is the odd term. So suppose what will happen if we have two even terms, that is for example we have this data. So over here we don't have odd term in between, but we have two values. So what we can do over here is we can directly consider average of these two values, that is 2 plus 2.5 divided by 2. So our median will be 2.25. Then third term related with central tendency is mode. Now what is exactly mode? In simple terms we can say most frequent value in the data set is nothing but the mode. So another example provided over here is 2, 6, 3, 9, 6, to 6. So maximum time 6 has been occurring. So 6 will be our mode of the given factor. So this is about the central tendency. So one example is solved over here. We can say the instead of directly coming to the design factor, we'll have a very simple general example. Suppose we are going to measure the heights of kids, and that height is measured up to the shoulders. So we have got different values, that is 600 mm, the another kid has the height of 470, 170, 430 and 300 mm. Now what is asked, we have to find the mean, variance and standard deviation. Now other two factors has come into picture over here, that is variance and standard deviation. So side by side we'll discuss two factors. Now we have the total values and we have arranged it in an ascending order, so it will be easy for us to understand other factors. Now we have plotted it. So we have 170 first value, 300, 430, 470, 600. Now if you want to calculate the mean, then directly we can have summation of all these values divided by total number of observations. So total number of observations over here are 5. So divided by 5 will be nothing but 394. So what does this 394 indicates? It is nothing but the mean of all this. So when we consider the mean and if we will plot it over here, we'll get it like this. So 394 will be our arithmetic mean for the collected data, and that data is related with the height of the kids. In similar fashion, if we are in the field of manufacturing, industrial fields, so we can have the dimensions of shafts, or if we consider gears, so number of teeth on gears, or either machining process. So there are number of examples related with our case, so we can consider and then we can find out the mean. Now what exactly it will relate with? So if we have found out the mean, that is 394. Now if you want to find out the variance, now exactly variance term indicates the variation from the mean value. So suppose this is the central tendency, and other newer, what we can say, values we have collected, how far they are. So suppose 170 is about 2 to 4, so we have a difference of that. There is 394 minus 170 will provide us this, or either we have 300 as the recorded value, then we can have 394 minus 300 as 94, but from left side we have negative value and towards right side we have the positive value. So all these values we call it as variance. So these blue color terms indicate the variation of the data, or we can say spread. So this is the another term, we call it as variation. So variance will indicate the square of all the spread divided by total number of observations. So variance is nothing but 21 or 21704 in this case. Now if you have to find out standard deviation, it is nothing but the square root of the given value. So if you want to define standard deviation, so it is nothing but defined as the square root of variance. So square root of this factor is 147.32. So 147 will indicate the standard deviation for this. So for that purpose we will require few formulas during our calculation part. So directly we can have variance as summation of x minus mean values divided by n minus 1 factors. Likewise standard deviation values we have in this case, or either if we have frequency, so we can use this formula, or either we have frequency with relation with the factors, then we can use this formula. So coming to the exactly what does standard deviation means. So standard deviation is nothing but a measure of how each value in a data set deviates from the mean. So it measures how concentrated the data are around the mean. That is, all the data represents. So what exactly standard deviation will consider? Suppose we have smaller the standard deviation, the value of standard deviation in our earlier case, that is 147. So if this value is reduced, so the data which is observed, suppose 170, 300, 470, 600 is too much concentrated, or we can say that maximum number of concentration of data is there. So this will be indicated by the term standard deviation. So for this case, So same case we have example is provided, and then we can find out variance with respect to arithmetic mean. We can use this and we can find out the standard deviation. So this is, or these are the small formulas related with the standard deviation. And then other sample, if we have a frequency related to that, and then we can multiply it with frequency, divide it with frequency summation, and then we can get exactly what the variation and standard deviation means. So another very good example, if you want to solve it, so 100 test specimens are provided for a component which is tested on ultimate tensile strength machine, that is UTM machine, and what we have to do is we have to find out the SUT. Now, so what are the results or observations for us is class interval is provided with respect to stress values, that is maximum megapascal. So 261 to 280, 281 to 300, likewise data is there, and how many times the frequency has occurred. So for that purpose, now mid term, that is mid value of this, we have to find out frequency polygon pattern. So we have got this one, and then we have frequency of occurrence. So this same table we have copied, and then we have fi into xi, which will be required for calculation of variance, and then fi xi square, which will be required for standard deviation calculation. So mean we can find out with the help of this formula as discussed earlier, fi xi upon n, and then sigma we have with respect to this. So variation will be nothing but simply when we have got as sigma 15.86, so square of this indicate the variance. So the simple numerical. So when we have understood all this, now we have to represent this data. Now since we have got a mean value at the central, that is maximum height we will have, so it will be distributed symmetrically. So this distribution will be called as a bell type of a shape we will get. So we call it as a bell shaped curve, and the concept is related with the normal distribution curve. So whatever data which tends to be around a central value, maybe 50% towards this side, 50% toward this side, so remaining observations are spread symmetrically about both sides. Now what exactly the factors which is to be considered, that is, we can get it, the things which are close to the normal distribution. So suppose height of the people is one example, or size of the things produced by the machine, or we have errors in the measurements, or blood pressure values. But when we consider related with our mechanical systems, so we have dimensions of gears, diameter of shaft, diameter of gear, or thickness of teeth. So there are a number of examples, and all this data is to be collected and is to be drawn with the help of a bell shaped curve. Now what is the significance of this bell shaped curve? So we have to consider standard deviation value. Now how much is the standard deviation value? It will depend. Now three cases we have to consider, that is, first one, if we consider three standard deviation value of the mean, then what will be the values which will be acceptable row zone, we can say. So 99.7% of the values are within the three standard deviation, or either when we consider 2 sigma, that is 2 standard deviation, we have 95%, and when we only consider 1 standard deviation we have 68%. So this value will be constant. Now exactly what is the significance, we'll try to understand. So for that we have to understand first the classification of normal distribution. So random normal distribution and standard normal distribution. The only difference in this case is we have to consider the two factors, that is a random variable and z variable. So suppose random normal distribution is to be understood, so that time central tendency mu value will have any value other than 0. So for that x value is to be considered, and the area under the curve we will be considering this. So x versus the function of x. And second we have standard normal distribution curve related with the natural or standard. So in that case we have to consider z, and area under this bell shaped curve always will be 1, and the central tendency will be 0, and spread of that will be that. So this formulas will be considering further. So what I was trying to tell you is, so random normal distribution mu we have, and classification from both we have other than 0 values. So x will be equal to mu plus sigma, mu plus 2 sigma, or either mu plus 3 sigma. So this is about the x factor which what we have to calculate. And when we move on with the standard normal distribution, we have z equal to x minus mu upon sigma. Now, if each data value of normally distributed random variable x is to be transformed into a z score, the result will be the standard normal distribution. So always the mean is to be considered the central value, and if you have to convert it, so that time we have to use this formula z as the standard constant term, which is x minus mu upon sigma, and then we'll get the standard normal distribution. But for calculating this, we required this table, that is standard normal distribution table. So instead of solving a numerical based on this, so we'll conclude for today's session and we'll continue in our next session. So thank you for today's session. So points related to design tolerance, numerical related to this, will be understanding in our upcoming series of mechanical system designs. So thank you once again.